Hey everybody, welcome back. Sorry I got cut off there. What I was going to say is on this video we'll be doing some more examples, how to find vertical asymptote, holes, and domain by hand. Here we are with our second equation, and we have x squared minus 9 over x squared minus 8x plus 15. So remember, the first step is to factor and solve the numerators and denominators. Numerator and denominator. X squared minus 9 factors into x minus 3 times x plus 3, and x squared minus 8x plus 15 factors into x minus 3 times x minus 5. Then we identify the zeros, or solve, of the numerator and denominator. The numerator, has zeros of 3 and negative 3. Both of those values will make the numerator equal 0. The denominator has zeros of 3 and 5. Both of those numbers will make the denominator equal 0. As you can see, we've circled, we have a match on the top and on the bottom of 3, meaning 3 will make both the numerator and denominator equal 0. That is where we will find a hole in our graph. The remaining 0 on the denominator is 5, so we'll have a vertical asymptote at x equals 5. And you can see that on this graphic. And of course, if you want to check out the graph, we can trace this to 3, and we should see a hole pop up. There it is, a hole at x equals 3. All right, for the domain, we simply take our denominator zeros, and those are excluded from the domain, so x cannot equal 3 or 5. In interval notation, negative infinity to 3, 3 to 5, and then 5 to infinity. All right. So our next equation is 2x plus 6 over x squared plus x minus 6. The numerator factored would be 2 times x plus 3. 2 times x is 2x. 2 times 3 is 6. The denominator factored would be x plus 3 times x minus 2. The zeros of the numerator, or 0 of the numerator, is negative 3. The zeros of the denominator are negative 3 and 2. So we have a match at negative 3, which makes both the numerator and denominator equal 0. There will be a hole there at x equals negative 3. Our remaining 0 in the denominator is our vertical asymptote at x equals 2. All right, for domain, we take the zeros of the denominator and we exclude them from the domain. So x cannot equal negative 3 or 2. Interval notation is written down here. Negative infinity to 3, union with negative 3 to 2, union with 2 to infinity. Okay, and there's a visual. There's our asymptote at x equals 2, and our hole would be at x equals negative 3. Next equation, x squared plus 4x plus 3 over x plus 1. Factored, we have x plus 1 times x plus 3 over x plus 1. The zeros in the numerator would be negative 1 and negative 3. The 0 of the denominator would be negative 1. So we have a match on top and on bottom of negative 1. Okay, draw a circle around it. That's where our hole is, at x equals negative 1. Now, there are no remaining zeros in the denominator. So that means we will not have a vertical asymptote. All right, now if we go down here to the graphic, we can see why. Okay, when we graph that, the graph of this rational function looks like a line, okay, as opposed to the two curves that we've been seeing. Okay, that does not necessarily mean that all rational functions will graph like that. They can actually turn out looking pretty crazy, or they can look just like a simple line. But this line will have a hole at x equals negative 1. Here are our inequality and set notations for domain. here is the interval notation for domain. All right, a couple more. X squared minus 36 over x squared minus x plus 8x plus 12. The top factors to x minus 6 times x plus 6. The bottom factors to x minus 6 times x minus 2. Hopefully you're starting to see that when we have matching factors on the top and on the bottom, that also means we will have matching zeros, which means we will have a whole. All right. The numerator zeros are 6 and negative 6. The denominator zeros are 6 and 2. All right. So we'll go ahead and draw a circle around our matching zeros, which means that's where the whole will be. Right. And then our remaining 0 on the denominator. I tend to box it. You can underline it. You can do whatever you want. But you don't even have to draw anything. But that remaining 0 will be where our vertical asymptote is. X equals 2. Here is inequality and set notation. As you can see, 2 and 6 are excluded from the domain. We go from negative infinity to 2, then from 2 to 6, then from 6 to infinity. Remember, all parentheses, okay? None of these zeros, none of these discontinuities are included in the domain, okay? There's our graphic with a vertical asymptote at x equals 2 and a whole at x equals 6, right? 2, 4, 6, 8, 10. All right, lastly, our last example problem. We have x squared plus 9x plus 18 over 2x squared plus 7x plus 3. The numerator factors into x plus 3 times x plus 6. The denominator factors into 2x plus 1 times x plus 3. All right, solving for the numerator, we get 2 zeros, one at negative 3 and one at negative 6. Solving for the denominator, we get 2 zeros, one at negative 1/2 and one at negative 3. All right, we're going to go ahead and draw a circle around the matching numerator and denominator zeros. That's where our whole will be at x equals negative 3. And then, like I said, I like to box the remaining 0, telling me that's where my vertical asymptote will be. Now, it's not necessary that there will always be just one vertical asymptote. There could be more than one. There could be none. There's not necessarily a whole. There could be one or more than one or 0. All right, it just depends on the original function. All right, so negative 3 and negative 1/2 are excluded. Remember, when we write domain, it's always least to greatest. So negative 3 is less than negative 1/2. All right. Again, if you want to go to the graph and do a little drawing, right, you can draw a line through the x-axis at your discontinuities. Here's one at negative 3. Here's one at negative 1/2. All right, and so you can see that the domain goes from left to right from negative infinity to negative 3, right? Then we go from 3 to negative 1/2. Then we go from negative 1/2 to positive infinity. And that's it. That's how you do it. All right. I hope this has made sense to you. If not, I'm sure your teacher can fill in any blanks or clarify a little further. But that is all I've got for you today. I hope you enjoyed it and have a blessed day. All that. Bye.